Now, what are the checks after floor plan? And what is the need of the checks? Already somebody answered very correctly. We need to check for the proper placement, or I should call it legal placement of the ports. Check for overlap of macros or physical cells. Right? What else is there? Checks after floor plan. By floor plan, we mean power plan also included, because physical cell placement will happen in power planning only. So check for overlap of macros or physical cells, right? Then check if all macros have halos. Check for well tap spacing. Check for power grid integrity. Means no shorts or opens in power. Right? These are the checks after floor plan. What is the insertion delay and skew? Mention the reason for increasing the insertion or decreasing the insertion delay. Yes. Insertion delay is nothing but the network latency, which means from the clock port, how much time does it take to reach the clock end of my endpoint? This is my insertion delay. Just a second. This is my insertion delay. Now, we all know that if there is the difference in insertion delay is the skew. Difference in insertion delay is the skew. Now we know that if there is positive skew, what is positive skew? As someone mentioned, capture latency is greater than launch latency. That is positive skew. And negative skew, capture latency less than launch latency, right? Simple. Positive skew is capture latency greater than launch latency. Negative skew is capture latency less than launch latency. Positive skew is good for, I need you to answer this. Is it good for setup or hold?
Setup
Setup,
for
sir.
post.
Right? So, if there is positive skew, it is good for setup. If there is negative skew, it is good for hold. Now, why I need to decrease or increase the latency? To play with the positive skew and negative skew, right? If I want to fix setup, I will increase the positive skew, which means I will increase the capture latency so that I will fix setup. If I want to fix hold, I will increase the launch latency so that I will fix hold, right? So that is why we will increase or decrease the latencies. That is why we have to increase or decrease the latencies. How will you minimize the insertion delay? Someone was answering addition of buffers and all. It is correct, but we have to dig a little deeper. Reduce insertion delay or latency. Let us say you have to reduce latency. Latency is nothing but again my propagation of my clock signal from the block port to the clock pin. Now, if I want to reduce my latency, simple. What are we doing in setup fixing? We are reducing the delay, right? In setup fixes, we are basically reducing the delay. Exactly same principles we will use for reducing the latency also. One thing is, we will find out why this much of length is required. Okay. Can we reduce the route length? Can we reduce the route length? Right? Is the placement of flop correct? We will first check that. Then drive strength of the buffers used. Whatever buffers are used are the clock buffers. Correct? Drive strength and VT. Means if they are all low VT, then it is fine. Let us say if they are all high VT, then they will have high delay. I have to change them to low VT. Likewise, if they are all 1x or 2x buffers, they will have very high delay. I have to upsize them to 4x or 6x. Next, routing layer. If I use M1 or M2 for this routing, definitely it will have more resistance and more delay, right? So I have to make sure I use proper layers for clock. By the way, in your designs, Leon or Orca top, what are the layers you used for clock routing? I want you guys to answer.
4, 5, 6
4, 5, 6.
for
Good.
Orca tops.
How many layers you had in Orca top?
9, sir.
9. Okay, good. So why are we using 4, 5, 6? Because Other layers are not free. Is that
These
correct?
layers will support for routing. So,
Yeah, correct.
we-
Yes. Understood. That's the answer. So top layers are used for power. M1 is used for follow pins or S routes. And for clock also we need good low resistance metals. So since top layers are used for power, next layers are used for clock. So 8 and 9 for power, 4, 5, 6 for clock, 7 again for routing. Why did we leave 7 and not use it for clock? Because if there are any critical paths in the design which are failing setup, those paths will also need low resistance wires. That will be taken care in layer 7. Got it? This is how will you minimize the insertion delay. What is skew latency, positive skew, negative skew we have seen.